we're here to discuss the future of fashion. I'm joined by 4 pretty amazing founders here. I'm just going to run through really quickly what, who they are and what their companies are, and then we'll get started. So we're here with Sean Peterson of Strong Arm Technologies, with Maddie Maxey of The Crated, with Francis Bottoni of Francis Bottoni Studios, and with Billy Whitehouse of Wearable Experiments. So I thought we'd just start out by posing the question that the panel has, which is what's the future of fashion? And then from there, we'll just have a really good conversation and kind of track what these 4 amazing minds are thinking about. So Maddie, why don't we start with you, if you want to just give us a couple minutes of what you're thinking.
Yeah, absolutely. I think that the question, the future of fashion, somehow gets separated from the question of the future of apparel, because fashion is a really easy thing to dissociate from, where people say, I'm not a fashion person, so it's not related to me, and apparel is something that's ubiquitous and everybody owns. Textiles, specifically as a base material, are everywhere from upholstery to spacesuits. So looking at not just the future of fashion, but the future of apparel and textiles, I think is an interesting question, because it comes down to a lot of material challenges of how do we embed intelligence into textiles, how do we make fabrics that are water resistant, stain resistant, and actually have clothing and the soft surfaces around us really meet our expectations. And I think that the future is really based off of enabling technologies and people pushing forward. So a lot of the work that's happening at material science companies, I think, informs the future of what we're capable of with fabrics, and can actually start to make smarter clothing based off of those material developments. So a long-winded answer to your question, but I think that the future of fashion is really about the future of materials. And the more that we make interesting materials, the more that it's possible to make clothing, or enable designers to make amazing things that serve our needs a little better.
Excellent. And Sean, let's get your perspective, because I know it's quite a bit different.
Yeah, it's sort of different. I mean, the way I look at it, I'm an industrial designer by trade. I don't have any fashion training whatsoever. And the way that I look at it is more so a vehicle. And what we've been able to do is, in the past with wearables, is we're diagnosing, we're understanding, and what I would really focus on is augmenting. And now what we're doing in terms of like the materials that we're working with, in terms of what Maddie's bringing up, and what we're able to understand, I see, for me, another vehicle, another medium for me to express what I'm doing in terms of augmentation. So it's like, where I see the future going is really augmenting what people can do, make them better, and take my platform, which are these big bulky exoskeletons, and embed them in something that's a little bit more streamlined. It just so happens to be called fashion because it's what we are so closely assimilated. And what makes that really exciting for me is that we're able to bring in super talented people who have such an expertise on that level of it in terms of the form and fit, which takes everything that I do an extra mile. And that's where I really think things are going to go. Excellent. And Francis, let's hear from you.
Yeah, that word fashion, I'm going to kind of echo some of what Maddie's saying. I mean, it's a very forbidding word. It alienates a lot of people. And I really like the work that we're doing in the studio, and most of what we get contracted for is really, in a lot of ways, it's transferring what we've been doing with consumer electronics to what we've been doing with a lot of hard materials, and trying to readapt them to something that's wearable. And I think, it's not so exciting to say like we're not really creating a whole new future, but I mean there are new kind of experiences that are afforded in that once you start to transfer a lot of what we know to the body already. But so much of what we've been like had our heads down on is really almost like process engineering. Like we're just trying to figure out like how to readapt a lot of these technologies to something that conforms to a human body. And yeah, so that's kind of where I think we're at right now.
Excellent. And Billy, how about you?
Whoa. So I think I agree with everybody that like we all have this unidentified future of what fashion really means in the future. And for me, it's always been more about empathetic design. And so I believe empathetic design systems is actually more of the future of fashion, even though fashion is this very strange word. And with that in mind, it means that we have to have an understanding of ourselves and the way we work in a way that we've never actually had to have before. And that means it's a biomedical problem, it's a materials problem, it's also an energy harvesting problem, because there isn't unlimited power in this situation if we are embedding these tiny microprocessors into our clothing, how are we charging them? And then this is a common problem for all of us, is that battery power is a huge issue. So how do we then create this empathetic system of design that then makes our fashion really easy?
So we've been hearing a little bit about like batteries that are based in fibers, batteries that are in a smaller form factor, more flexible, and so on. Do you see any revolutions on that side that's going to open up what you're able to do with the clothing that you're working on?
Well, Francis and I were just having a conversation about mushroom fibers and this wonderful idea of being able to print in mushroom fibers and teach them a learning algorithm.
It's really hard to print mushrooms.
So it's really difficult to do, but in an ideal scenario, it's not like this gooey, disgusting fiber, but it can be a nylon or a cotton, and it can resemble those qualities. And then you could expand and contract it, and you could create power. This is all very hypothetical, by the way. This isn't an ideal scenario.
Yeah, I think the question you have to ask yourself around batteries is really, what are you trying to do? And you know, can you do a lot of this with lower energy components? Like a lot of what we've been kind of looking at lately is just reducing the amount of power that's needed. Because it's not really that like battery technology is so bad. It's just, you know, yeah, it's bulky and you're putting, but it's also, you know, a lot of the packaging on our batteries, it's not that they're so bad, it's like they can be broken up. Like you could kind of take the same technology that's in an existing battery and give it a different form factor, and it's going to still have the same, you know, it's going to have the same effect. So I don't think that we necessarily need like a huge revolution in battery technology to make this work. I think we just kind of need batteries that are packaged up as different products to suit a certain application, and that's something that if there's a gap, that's what we're missing.
Mm-hmm. When you're talking about different form factors, I'm wondering if you could break down really quickly like what's current, where are we at now, and where do you see kind of the future on that side going? Because I know that, Sean, it'll also play into a little bit of what you're looking at as well as how much power is necessary for an exoskeleton and so on.
Yep.
So, Francis, what's the current state of what you're working with? And
yeah, I mean, we're really focused on materials, so I'm not like a battery expert. You know, I think we integrate with people who are doing electrical systems, so like I kind of look at this from the outside. I think probably Sean or Maddie can give a much better description of this.
Yeah, absolutely. So for us, it's a matter of figuring out what holds a charge and what you can embed that stuff into, and that's what we've been focusing on. And in terms of making that as an interim solution a little bit more accessible in terms of embedding it in things that you're going to actually wear. So that's been a really good approach. But more so what we focus on is try to, since our limitations are really that battery power, is focusing on what you actually need from a design process from day one. So when you open up your sketchbook, you have to think about it from an optimization standpoint. What do you need, and then what can you not live without? And when you're working with that in that design process, how can you make that the most efficiently, you know, streamlined process possible? For what we do, a lot of load redistribution things, you know, actuated by what's available and, you know, the kinetic energy that's stored within the system to allow it to do what you have to do, and then figure out how you can recover a lot of those things. So if there's something that could generate its own power or its own momentum or its own actuation, that is a real amazing way to start focusing on it, so that we don't have to go down this kind of, you know, in-between way of making these weird kind of battery thingies, right?
I feel like I kind of agree with everyone in different ways, which is fun to hear everybody talk about the issues that they're facing and what they think good solutions are. I mean, I think that when you're dealing with textile circuits and wearables, especially in fabric, you're dealing with large surface area circuitry. And that's kind of a different challenge than what typical li-poly batteries are made for, which is very condensed. Like, you want it as small, compact, often thick, kind of heavy as possible. And so something that we've been really curious about lately is if you can spread out a battery over a large surface area, kind of as Francis was saying, how does that open up options for flexibility and a change in form and function? I mean, we've been working with a lot of thin film rechargeable batteries, and they're limited in terms of power output, but they're also not really soft. They're not things that we're used to dealing with. And so I guess this is more hypothetical, but when we think about batteries as something that don't need to be as compact, I wonder how that opens up opportunities for spreading them in ways that can feel like the fabric that we're used to. Yeah.
So Maddie, we were talking a little bit earlier about how we're kind of at this point where we're building the enabling technologies. We're building the start of what the future is going to be. And Billy, you were talking about this a little bit as well. And so I was wondering if each of you could just give a picture of where you think we'll be in 5 years based on where we're at now, and what you're pushing towards and how you want to accelerate that. So Maddie, if you want to start.
Sure. I was really curious about the future speculation questions because I really don't know, and I would quite like to know what's going to happen in the future. But I think that a lot of work that's happening in terms of like Clothing Plus being acquired by an electronics company or DuPont focusing on these stretchable conductive traces says a lot about more hardcore material science and electronics companies getting interested in the space. And I think that when people with big budgets and engineers can work on these problems, that it really speeds up the rate of growth. And so I'm hoping that we'll just have more functional clothing, heated jackets, like haptic feedback, like a lot of what Billy's doing, in a way that's easy to manufacture and more accessible, so that they're not luxury items, they're just what we expect from the things that we wear.
And how about you, Billy?
So there are so many challenges still, but in the 5-year spectrum, I think we're really looking towards like an end-to-end feedback loop solution. So at the moment, so many wearables, it's such a dirty word to me, are really determined around data, and a lot of these companies are now pivoting into these data companies because data is becoming so valuable. Sorry, data means data. And I think that instead of just collecting all this data and then really not knowing what to do with it or how to make it personal for anybody is part of the problem we're trying to solve. So how do we make data sexy and meaningful? And that to me is the problem we're trying to solve in the next 5 years.
All right, and Francis, what do you see? Yeah, what do you see coming up in the next 5 years? What are you working on now that you think you can push out?
Yeah, I mean, most of our work is around the 3D printing space. I mean, we've been, as far as like internal R&D goes for us, we've been looking a lot at printing soft conductive materials. And we've been doing a little bit of research into printing, not necessarily printing biomaterials directly, but like what kinds of, could you print materials that will grow or be scaffoldings for growth to get something that could be organic. I don't see that happening in the next 5 years, to be honest with you. I mean, I think like a lot of the barriers with what we're working on is like process integration. I mean, there's no factories that are like full of 3D printers that are ready to kind of do any of these things at any kind of reasonable scale. And then also the question is really, why do you want to do that, right? And I think like the issue is like what's the industry doing? Like what kinds of products are people like this making, and what are the demands going to be? I mean, 5 years is not really that far off, especially like for hardware. So I think like if you really want to know, I think just probably look at what the people on this stage are making. And I think a company like ours is really just trying to service and enable that. And I actually would say like the stuff we're working on might be like 10 to 20 years away. I mean, it's a lot of it's just, it's very speculative. I mean, we're imagining a future of like what these technologies might mean for production, but like, is there going to actually be a demand? I mean, I think it's like the fiber battery thing. Like, do we really need a fiber battery? Because we can't use any of the manufacturing processes we use to make batteries right now. So do we want to develop all those processes? I'm not sure if there's going to be an economic incentive in the near future for a lot of what we're working on.
Okay. And Sean.
Yep. So
Always optimistic.
Out of everyone's horrible frustration that's on the stage, I think the most, like the message you can get out of here is why, right? And I think the most important thing that we all have to do our part in is the education forefront. It's like, why do we think that these things are important? And that'll help us shape the way. So that also ties into why you make data sexy, and it ties into, you know, how do we understand a little bit more about what people actually need and where we can have the most, you know, the most poignant effect on whatever it is that we do. I do think that there are a lot of cool things that we're doing in terms of what we're doing in the warehouse forefront, where it's very specific niche use of exactly what people need, and you can have a real-time benefit for it. But it's, again, how do we educate that for the everyday consumer? How do we educate that into other markets to see where people really need that, so that we can apply these same design tactics? And then we're just built in the same constraints that exist right now in terms of, obviously, battery power and the implementation. But I do think that, especially with what people like Francis are doing in terms of embedding a lot of the structures and what everyone else is doing on the stage in terms of embedding those sensors into a more plausible methodology, technology. I think we're going to get somewhere that's pretty cool. I don't think we're all going to be wearing jetpacks in 5 years, maybe 10 years, but not 5 years for sure. And I just think that it's really about educating and understanding from a better perspective where we need these things and why.
So we recently went through kind of a focus upswing, I guess, on the word wearables and how exciting it was going to be. There would be all these gadgets that we'd have that we could strap on and so on. When do you think that word is going to disappear and we're just going to refer to clothing? Where do you see that kind of changing inside of our language?
Well, there's no interface, right? So we're never going to get away from your phone, so we're never going to get that far out of it until someone figures out a way to actually have an interface to interact with whatever the hell it is that you're wearing.
Which takes a hell of a lot of processing power. I don't believe that this term wearables is like a nice term. I think it unfortunately belongs to like the arm candy that people like, the arm party now with so many devices that sit on your wrist. I prefer to just call it ready to wear. It makes more sense to me. We've been using enabling technologies in fashion forever. Whether it's a knitwear machine, whether it's a zipper, these are all technologies. And so for some reason now that it's got a microprocessor in it, we now want to give it this title of wearables, which is just really dumb.
I mean, the question is, like, when are we going to be motivated to put a microprocessor in every garment? And I'm waiting to really see it should, like, when we reach a point where it's standard that every blazer I buy has a microprocessor embedded in it, like, then it'll be clothing, right? But until then, now it's like, it's this kind of specialty product that's divorced from the traditional supply chain of how you manufacture a garment. So it's a big hurdle for a brand to learn all that. They don't have a history of making consumer electronics. Very few people have a history of making soft electronics.
That's why they come to me.
Exactly, and exactly. That's why Billy's, is awesome.
Or you.
Is awesome. But, well, yeah, in different ways. But it's, so this is this thing. So like it'll happen when the sensors and processors are ubiquitous.
Totally, and I also think that it's interesting to see how language has evolved over time for these weird hybrid things in history. So it's like the car was known as the electric horse and buggy until it was given an actual name like a car. And I think wearable technology is the same hybrid where we're like computer technology, like object on the body, wearable, like let's plug this together and make it a word. And if you look up wearable on Wikipedia, there's just like really nothing there because you've never needed to say wearable to describe your shirt or your pants. It's just like redundant. So I like Billy's point of view of calling it ready to wear because we've got to get to a point where names evolve and where there's better language for a lot of these things. And I think that also creates a lot of the communication issues that Francis was mentioning, where half the time nobody knows what the other person's actually referring to, especially when it comes to bringing electronics in with fashion brands and companies that make apparel.
And a couple of you have brought up the manufacturing constraints right now and how right now it's almost a bespoke process at times for certain types of technologies, getting them into the clothes. So although we have the technology to produce the sensors, produce the garments, we don't have the technology to mass produce them. And I'm wondering, so we're about 30 years behind in the US on manufacturing tech, and there's not all that many people focusing on that. Where do you see the actual innovation happening on the supply chain and the production side? And do you think there's a place there that people can be focused on in the US as well? And then that'll be the last question.
Well, I know we're manufacturing, and we are manufacturing for scale, and we're manufacturing in Sri Lanka. They're currently flooded, which is not ideal. One of my co-workers is marooned. That's like, for us, that was the key of working with them, was they'd figured out some of the integration problems and the washability problems, and we wanted to solve these problems.
All right, perfect. I'm getting the signal that we actually are out of time, so we're going to cut the panel short. If you have any questions about it, find us in the crowd, and we'll have a conversation.
Thanks.